Welcome to the lecture of artificial intelligence. In today's lecture, we are going to talk about the fourth unit of this particular subject, that is game playing. So game playing is one of the application of artificial intelligence, right? So many researchers have done so much work into this particular area, that is game playing. So let's start. And again, in this particular scenario, we are going to talk about only basic games like chess, tic-tac-toe, and we are not going to talk about higher level games like PUBG and all. So let's start. So there is one concept of adversarial search. So we will talk about it, but uh, let me summarize what we have seen so far. So the problems we have solved previously, they were like, we were having some problem, we were having some agent who was trying to solve the problem into some search space, right? But what happens in this case, there is one problem, but more than one agent is trying to find out the solution of that problem into a same search space. So whenever a single agent is trying to find out the solution for any problem, he know what he is going to do. He will take one move, then he will take another move, then he will take another move. So all moves are depending on his situation, right? Or his it was his own decision. But what happens when there are more than one agent is trying to find out a solution into a same search space? Let's say there are two agents, then agent 1's move is depends on what move agent 2 is taking, or agent 2's move depends on what move agent 1 has taken. So this is the scenario of gameplay. So there might be some situation where more than one agent is searching for the solution in the same search space, and this situation usually occurs in a game playing, right? So in this type of search, we try to examine the problem which arises when we try to plan ahead of the world and the other agent are planning against us. Now, the environment where there are more than one agents are working is known as a multi-agent environment, in which each agent is an opponent of the other agent and playing against each other. Each agent needs to consider the action of the other agent and the effect of that action on their performance, right? So searches in which two or more players with conflicting goals are trying to explore the same search space for the solution, and it is known as a game, right? So games are modeled as a search problems and heuristic evaluation function, and these are the two main factors which help. Now there are two types of games. First is deterministic game and second is non-deterministic game. So deterministic games are games in which rules and regulations are strictly followed. For example, chess, right? So we know all the rules and regulations of the games. And non-deterministic games in which the games where the rules and regulations are not that much strict and that are most probably depends on luck, right? Or the move of the opponent, or we can say there is a randomness into the game. Now again, there are two types of games, perfect information and imperfect information. So in perfect information, we know all the information about the game, we know all the rules and regulations about the game, for example tic-tac-toe or chess. And imperfect information, so the game in which we don't have all the knowledge about the game, that is known as the imperfect information. For example, a poker, for example poker. So this is what we have talked. Perfect information, when we have all the information about the game, for example chess. Imperfect information, where agent do not have all the information about the game and he is not aware what's going on. Such a type of game is known as imperfect information. Then next is deterministic games, where rules and regulations or strict patterns are followed. There is no randomness. For example chess, we know all the moves or how the players move. So that is example of deterministic game, that is chess. And second is non-deterministic games, where there is a randomness or the there are so many factors which are not predictable, or we can say there is a factor of chance or luck. For example, poker. Now there is a one more concept known as a game tree. So what is game tree? Game tree means where nodes of the trees are the states of that game, and edges will act as a moves that player has taken. So that game tree involves initial state, action function and result function. So there is one example of game tree. So this is a game tree of tic-tac-toe game, right? So let's say there are two players, Max and Min. So let's say Max is playing first. So when Max is playing, as there are nine boxes, that is, this is a game of three. This is 3 by 3 game of tic tac toe. So there are 9 boxes available. So let's say Max is one player who is going to play first. So Max is having 9 options with him. He can put cross into any of the 9 boxes. So he is having 9 boxes. So let's say he choose first box and he put cross into the first box. Now there is a second player known as Min. So Min will play. Now Min will having 8 options with him to play. So now Min will play. Now depending upon the move taken by the Min, Max will take his move. Again, when Max will take his move, depending upon the move taken by Max, Min will take his move. So this is how the game tree works, and this is how the game works. Now there is one more concept of utility. So utility means the points that you will gain. So -1 means if you lose, 1 point will reduced from your amount or account. If there is a 0, it means the match is draw, and if there is a +1, if you win the match or if you win the game, +1 point will get added into your side. So this is about some basic concepts of the game playing. So today we will stop here. In next lecture we will talk about 2 algorithms, that is minimax algorithm and alpha beta pruning algorithm. So this is about game playing. So let me summarize it into a few minutes. So first of all, whatever search problems we have solved previously, there was only one agent who was trying to search for the solution into a search space, right? What happens in game playing? In game playing, there are multiple agents, like there are more than 2 agents who are trying to search for a solution into a same search space. Now, whenever that 2 agents are acting opponent to each other, so agent 1's move will depend on what move agent 2 has taken. So this is how it works. Then there is a concept of game tree, right? So in game tree, we have seen the game tree of tic-tac-toe, where nodes act as a states and branches acts as a move taken by the player. There is one concept of utility. In this case, utility means the point that you are going to get. So if the point is -1 means you have lose. If point is 0, it means match is drawn, and if point is 1, the +1 is added into the account, right? So this is how it works. Now there are 2 types of games, right? Deterministic and non-deterministic. In deterministic games, the rules and regulations are strictly followed. In non-deterministic games, there is a randomness into the game. The game is not predictable. It depends on chances or luck. Second is game with perfect information, where we have all the information about the game, like chess, and imperfect information, where we don't have information about the game, for example tic-tac-toe. So this is about game playing introduction. In next lecture we will talk about minimax algorithm and alpha beta pruning. Thank you so much.